Next to the number system is called natural numbers, or they are also called counting numbers. Why? Because we start counting from 1, 2, 3, 4, etc. We find 1 is the least natural number. Definitely there is no greatest natural number. Next to the number system is called whole numbers, denoted by W with the inclusion of 0. It goes on. We find every natural number is a whole number, which means n is subset of W. Third set of numbers is called integers. This contains all negative numbers, positive numbers, and 0. So we can say integers is a set of natural numbers and their negatives with the inclusion of 0 forms the set of integers. Now we find whole number system is a part of integers. Rational numbers. The notation is Q. Numbers which can be written in the form of P by Q, where P and Q are integers and Q not equal to 0. They are defined as rational numbers. Look at the examples of rational numbers. Anybody will say 1 by 2, 2 by 3. If you have to press further, you get minus 1 by 2 and minus 3 by 4. Further coding will give me 0. Then minus 2 is nothing but 4 by minus 2, or 3 is equal to 6 by 3, which means every integer is a rational number. So natural number system is subset of whole numbers, subset of integers, subset of rational numbers. Next we will define what are irrational numbers. We can generalize saying numbers which are not rational, they are irrational numbers. That means numbers which can't be expressed as a fraction, like root 2, root 3, even pi is an irrational number. Definition of pi is circumference of a circle to its diameter. Why it becomes irrational? Because circumference of a circle is a curve and you can't divide by a linear length. A curve cannot be divided by a linear length. That means indivisible numbers are called irrational numbers. Into a number system called real numbers, R. So n is subset of W, subset of Z, subset of Q, subset of R. Real number system is a number system consisting of all those number systems we have discussed above. And primarily numbers are divided into two categories. prime numbers and composite numbers. What are prime numbers? We have seen 2 is a prime. Why? We'll understand now. 5 is a prime, or 4 is a composite number. The reason is, if you look into the factors, how many factors a prime number has? So we can describe numbers having exactly 2 factors or prime numbers. So school days we have seen numbers having only 1 and itself. So 1 and itself means what? Only 2 factors. So, and we know 2 is the least prime and 2 is the only even prime. All these known factors. How will you define composite numbers? Numbers having at least 3 factors or composite numbers. Instead of telling more than 2 factors, at least 3 factors guarantees something. And we can define what are coprime numbers. The other name is relatively prime. One more name is mutually prime. So what are these numbers? We'll look into this. Coprime numbers. I'll give you 3 differences. Number 1, 2 and 3 are coprime. Why? Number 2, 4 and 5 are also coprime. Think why? Number 3, 8 and 15 are also coprime. What do they have in common? Highest common factor is 1. So you can understand numbers having highest common factor is equal to 1 will be called coprime numbers. Why 3 different sets? What about 2 and 3? Both 2 and 3 are prime numbers. So what we can generalize? Any 2 prime numbers are always coprime. Okay. Number set 2, 4 and 5. What are they? They are consecutive positive integers. So generalize saying that any 2 consecutive positive integers are also coprime. Coming to the third side, 8 and 15 are composite. Still, they are coprime. Why? Because their highest common factor is 1. Why I am saying this? When I say coprime, you can think of only prime numbers. Prime numbers are always coprime, but that's not the case. Numbers can be both composites, still they can be coprime. Prime or coprime depending on the number of factors. So, now the job is to find the total number of factors to a given number. Let us take some number, say 36. If you write 6 into 6, break into prime factors. Again 2 into 3, expressed in index form. Now the number of factors are given by increasing the index by 1 and multiplying. So 3 into 3, you get 9 factors. So step 1 is what? Break the number into its prime factors. Step 2, express them in index form. Step 3. Increase the indices by 1 and multiply, you will get total number of factors. If you have a number like 8 to power 3, so number of factors is, it is only 3, 2, so how many times? 3 times. 8 plus 1, 4 factors it will have. Let us see, 54 is 2 into 27. You can write 2 one time, 3 times. So the number of factors will be 2 into 4, 8. Let's take 225, which is 15 square. 3 square into 5 square. Number of factors is 2 plus 1 and 2 plus 1, which is 3 into 3, 9.